Okay, now we're going to look at section 3 of the review chapter, factoring polynomials. So we're going to look at different ways of factoring. The first one is factoring out a greatest common factor. If we can do this, the first thing we want to do is find factors that are common to each term. So things that are multiplied in each term that each of the terms have. And then we're going to bring those common factors out in front of parentheses. So if we look at the example we have, we see that we've got a factor of 2 in each of the terms. So if we look at the 2 coefficient in the first term, we have 2 times 1, and then the 8 can be broken down as 2 times 4, and the 2 can be broken down as, again, 2 times 1. Okay, so that's one of the common factors, so we're going to bring that out in front. I'll just write that here for now. And then if we look at the x's, we see that the first term has x cubed, x squared, and then just x, which would be like x to the 1. Okay, so the common factor there is x. We can bring an x out in front. And we're going to bring that out in front of parentheses, and in the parentheses we write down what's left after we take those factors out of each term. So if we take if we take a 2 out of 2x cubed, we're going to be left with a 1, all right? But we don't actually have to write that. If we take an x out of x cubed, we're left with x squared. And then we look at the next term, include that plus sign. If we take the 2 out, we're going to be left with that 4, so we get plus 4. And if we take an x out of x squared, we're left with x. All right, when you look at the next term, so we have that plus sign. And if we take a 2 out of the 2, we're left with a 1, all right, but we typically don't need to write that. And if we take an x out, we are left with a 1 as well. So what we end up with is a plus 1 here, okay, because what we bring out in front exactly matches that third term. So if we bring that out in front as the common factor, we're left with a 1. Okay, so this right here would be the factored form, bringing out the greatest common factor. All right, so let's look at another example. Let's look at -5 y cubed plus 15 y squared. So we want to identify what common factors there are in each of the terms. So if we look at the coefficients to start off with, we can see that there's going to be a 5. That's common to both the 5 and the 15. Now there's a negative in front of that 5. So we can either leave that negative inside the parentheses or we can bring it out in front. I actually always like to bring it out in front. I think it makes it simpler. So I'll bring a -5 out in front. Now if we look at the y's, we've got a y cubed and a y squared. Okay, we can take out a y squared. So that's our greatest common factor. Now we have to write down what's left in the parentheses. So taking the first term, if we bring out a -5, we're left with a 1. Okay, but we don't actually write that. If we take out a y squared, we're left with just y. All right, so it's positive because we took the negative out. All right, if we take a -5 out of 15, out of positive 15, we're going to be left with 3 as the factor, but because we've taken a negative out of a positive, we're left with a negative. And the way we can check that is if we think about what happens if we multiply -5 times -3. -5 times -3, well, that gives us back to that positive 15. So if we take a negative out of a positive number, we're going to be left with a negative. And if we take out the y squared from 15y squared, we're going to be left with a 1. So that just stays as -3. All right, so let's get rid of that parenthesis that's way out there and put it closer. Okay, so that's our final factored form of that polynomial. Okay, let's look at this one. So at first it might seem like we need to do some distributing, multiplying out before we do anything, but if we notice, we have in the first term here, which would be this chunk right here, you've got an a minus 1. And then the second term would be this chunk. We also have a factor of a minus 1, that quantity in the parentheses. And then in the third chunk, all right, we also have that factor a minus 1. So in this polynomial, if we think of those things that are designated by the black as each being a term, each of those terms shares that common factor of a minus 1. So let's bring that out in front. And then now in parentheses write down what's left over. So from that first term we're left with a 2a squared. And the second term we're left with a. And what are we left with in the third term? Well, if we take that a minus 1 out, it leaves us with a 1, and then there's a minus in front of it, so it's a minus 1. Now let's look at factoring by grouping when we have a polynomial with more than 3 terms. We're going to come back to factoring by grouping for trinomials, but first we're going to look at when we have something like this. All right, let's take 4x cubed plus 2x squared minus 2x minus 1. Okay, so it might look too complicated for us to do, but what we're going to do is we're going to break this into 2 greatest common factoring problems. And we're going to do that by grouping together the first 2 terms like this and grouping together the second 2 terms like that. All right, now we are going to treat each of those like we are taking out a greatest common factor. If we look at the first group, the 4x cubed plus 2x squared, we see that we can bring a 2x squared out in front. That's common to both of those terms, and we're going to be left with a 2x. And then what are we going to be left with from the 2x squared? Well, there's just going to be a 1 left. Okay, now we look at the second group, the negative 2x minus 1. Well, from the first term and the second term, the only common factor is a negative 1. So we'll bring that out in front. And then what we're left with is a positive 2x, and if we take a negative out of a negative, we're left with a positive again, so we get plus 1. We're not quite done, because notice now we have a common factor of 2x plus 1 that we can bring out into the front. So bring out 2x plus 1, and from the first term, this first kind of chunk of numbers, we have left over a 2x squared. And from the second chunk, what are we left with? If we take out the 2x plus 1, well, we're left with a negative 1. All right, so that fully factors that polynomial. Now let's look at factoring trinomials, and those are polynomials with 3 terms. We run into this a lot when, especially we're going to look at quadratic functions. Okay. So we're going to start with maybe the most straightforward kind of example. We're going to start with a quadratic quadratic polynomial that has a leading coefficient of 1. So just terminology I use there of quadratic. A quadratic polynomial is one where the highest degree is 2. And when we have that, we call that a quadratic. Okay, so I think I mentioned that it's the opposite of FOIL. So remember, when we can FOIL to multiply 2 polynomials is when we multiply two polynomials that each have two terms, and those are called binomials. And we can be even more specific. To get this x squared, the only way to get that x squared is if we have an x in the first position of those two linear binomials. Because if we think about multiplying these two linear binomials, to get that x squared, we're going to multiply the first times the first. So if we're factoring a quadratic polynomial that has a leading coefficient of 1, we can just immediately write down the parentheses and write down an x and an x in there. Okay, so let's figure out how we're going to fill in these other positions here. All right, well, to fill in those positions, we want two numbers that multiply to the constant of 12 and also add to the coefficient on the x term, which is 7. Okay, so those two numbers are going to be 3 and 4. So if we plug those in, so we get x plus 3, x plus 4. We can always check our work by multiplying. So if we take what we've just got, x plus 3 times x plus 4, and now multiply those, all right? So we do first times first, we get our x squared. Outer times outer, we get a 4x. Inner times inner, we get 3x. And last times last, we get 12. And then combining those middle two terms, we end up with what we started off with. Okay, so that's the easiest, most straightforward way to factor a trinomial. Now we're going to look at a trinomial that's a quadratic, but the leading coefficient is not 1. So 6x squared minus 7x minus 5. All right, it's still going to factor into two linear binomials like that previous one did, but we've got this linear, or we have this coefficient that's not equal to 1, and so we have to figure out how we're going to end up with that 6. Okay, so I'm just going to go through a step-by-step way to do this. It's an application of factoring by grouping, like we looked at before. But first, we have to split this middle term up into two terms. So I'm going to go through some steps to this method. If you have another method to factoring these kind of quadratics, you are more than welcome to go ahead and do that. The textbook actually has you kind of do a trial and error method, which you're welcome to do that as well. Okay, but the step-by-step method, first thing we do is we multiply the leading coefficient and the constant term. Okay, so the 6 times the negative 5, and we get a negative 30. And the second step is that we want to find two integers. Okay, so whole numbers that can either be negative or positive, that multiply to negative 30, that number that we just got, and add to the coefficient on the x term. So in this case, that's a negative 7. Okay, so this is similar to what we did when we had leading coefficient of 1, but we have to do that first step of multiplying the leading coefficient by the constant term. Okay, so here is where we can maybe do a little bit of trial and error to figure out what that is. So we want to multiply to negative 30, and we want to multiply, and we want to add to negative 7. Okay, well, negative 30 we could get as negative 5 times 6. Well, that doesn't add up to negative 7. We could do negative 6 times 5. That doesn't add up to negative 7. We could do 10 times 3. That adds up, or I'm sorry, 10 times negative 3. That is a positive 7, but we want a negative 7. So if we put in a negative 10 and a positive 3, That's going to satisfy both of those conditions. Okay, now we're going to replace the 7x, replace that x term with two x terms that combine to make 7x using that negative 10 and the positive 3. So we can rewrite negative 7x as negative 10x plus 3x. And we're going to replace that negative 7x in the polynomial. So the polynomial will then become 6x squared plus 3x minus 10x minus 5. Okay, so this is because negative 7x is equal to negative 10x plus 3x. All right, we can just make that replacement. All right, now here is where we get to the grouping part. We group and factor like we did before. So let's group the first two terms together, the second two terms together. If we factor a common factor out of the first group, we can bring out a 3x. We'll be left with a 2x plus 1. And from the second group, we can bring out a negative 5. And we'll be left with, what do you know, 2x plus 1. Okay, so that gives us something like we had before, and we recognize that we have the common factor of this quantity, 2x plus 1. We can bring that out in front. And from the first group, we have a 3x left, and in the second group, we have a negative 5. And so that is that polynomial factored.